The terrain you're looking at was generated using a 3D Perlin noise function and the marching cubes algorithm. So how the algorithm works is it breaks the landscape up into a 3x3x3 grid of cubes, thus marching cubes. In this particular instance, the grid is 512 by 512 by 512 cubes. And then it iterates over every single cube in the grid and executes a function on each corner of each cube. Depending on which corners of the cube are considered to be inside the terrain, it will calculate the triangles that need to be drawn to represent that cube or that portion. These triangles are determined using some very, very long lookup tables that I do not recommend calculating by hand. You can find them online very easily. So, each cube can generate up to 5 total faces based on the 15 possible combinations of vertices that are considered inside the terrain. Now we have a number of variables that you can see in the control panel that we can change to affect our terrain. One at the very top is the cell size, so in other words, how big is each cube. Right now they're set to be 2 by 2 cubes, so we're actually skipping values in our noise map. So one corner of the cube will sample from a certain point, and then a vertex to the right of it will sample 2 points down in the noise map. What this means is that having a cell size of 1.0 will give you the most accurate representation of the noise function, because each vertex directly corresponds to its own individual value in the noise map, and we're not skipping over anything. So having a cell size of larger than 1, you're going to be skipping values in your noise map, and having a value less than 1, you're going to have, it's possible you could have 2 points sampling from the same, or approximately the same, in location in the noise map. So here we've now changed it to 1, and you can see that the cells are visibly smaller, and the terrain does look slightly different, not a whole lot, because the difference between having a cell size of 1 and 2 isn't that great. We'll mess around with this a little bit later to see how drastically it can change things. The next variable that we can change is the sampling ranges. So when we're generating our height map, we run the Perlin noise function on a certain range of values. So what is the value of Perlin noise from x equals 0 to x equals 1, or y equals 0 to y equals 1. And this can be any combination, any place in the noise function. And this is what really determines what your terrain looks like, is what chunk of the noise function are you trying to represent. So initially we were sampling from x equals 0 to 5 and y equals 0 to y equals 5, and that gives us a pretty varied terrain. But here you see that if we sample over a very small range, we really don't get much variation. I mean, the noise doesn't vary a whole lot between 0 and 1. You kind of just get one curve, and that's what you see here, just one kind of big, one not even very exciting mountain. So sampling over a very small range gives you pretty boring terrain. Sampling over a very wide range can give you very drastic terrain. So now looking at some of our presets, you'll notice one says Minecraft-ish. It's ish because we don't snap our vertices to integer values, so it's not quite as blocky. But you will notice a similarity, and it's achieved by sampling over a wider range of values, in this instance 0 to 10 in both x and y, and also having a very small cell size. So across one cube we're sampling at almost or functionally the same point in the noise map, so each cube is at the same height, essentially. You'll see sometimes that's not quite true, but over most of the terrain that is true. And this effect is a lot more visible if we sample on a smaller range, say 0 to 1, which I'll show you here in just a minute. And you'll see that kind of rolling hill, kind of blocky Minecraft-ish kind of look. So as you can see here, we do have a little bit more of that rolling, blocky kind of thing that I was talking about. So you can have a lot of fun changing these variables. I definitely haven't exhausted all the possibilities. You can sample from any range in the noise function, so there's functionally limitless terrain variations that you can come up with just from changing the sampling ranges, throwing all the other variables on top of that. Definitely adds even more possibilities. So if we sample over a very wide range with a very small cell size, you'll still see the blockiness, but we're going to have very drastic, spiky kind of terrain, thus the preset name Spires. As you can see, things have gotten a little crazy here. We have a lot of really drastic changes in elevation. That's because we're taking a wide range of noise values and condensing it down to fit into here. So this is, you can kind of see the spikes and dips in the actual noise function here. Now if we keep the same sampling ranges but increase our cell size to 1 or 2, we'll see very, very interesting terrain. Not something you would ever want to use for like a video game map or anything, but it's still pretty cool to look at. And here you can really see the rolling waves of the Perlin noise function. One last thing we could try is a lower poly kind of look. This is achieved by keeping a reasonable sampling range but increasing our cell size. So here it's 5. You can't really tell a huge difference, but if we increase it to say 10 or so, then you'll notice that the cells do get noticeably bigger. So here you can see the cell size of 10 rendering, and as you can see, it does have a lower poly look. I haven't tested this by going to an extreme value like 50 or anything like that, but you can definitely see the effect here.